This is Junior Roberts from realjuniorroberts.com. In this video, we'll be talking about transistors. Okay, so transfer resistors, or transistors for short, are three-terminal electronic components which can be used as switching elements or for amplification purposes. Now, I usually consider a transistor the closest relative to a diode, since a transistor is actually made from three silicon slabs arranged in such a way to make a transistor. Right, there are quite a number of transistors and various types, but we tend to categorize transistors in two broad groups, which are bipolar junction transistors, or BJTs, and Field Effect Transistors, or FETs. Right, as I said, there are quite a number of transistors, right, but we tend to categorize them into the two broad groups. Right, and as I mentioned earlier, right, a transistor is a three-terminal device, right, so as you can see, here I have some examples of some transistors here, and they all have three terminals. Right, these are some transistors which we tend to use for amplification purposes. Right, these are some BJTs, and they are further subdivided into a positive type BJT and a negative type BJT. Now, the positive type BJT is called a PNP transistor, and the negative BJT is referred to as an NPN transistor. Now, our transistor work, right, is it actually requires a small current. Well, first of all, let me actually talk about the three terminals of the transistor. Right, so this is a typical transistor that we might use, right, and the terminals are, looking at it from this angle, the emitter, the base, and the collector. Right, so those are the three terminals for the BJT. Right, on the other hand, for the FETs, the terminals are the gate, the source, and the drain. But as I said, we won't go into much of FETs, right? That probably would be outside the scope of this video series, right? So we'll stick to the BJT and look at the terminals to be the emitter, the base, and the collector. Now, in terms of our transistor work, it works by a small current at the base controlling a much larger current at the collector. So if we were to think of a transistor's operation synonymous to, let's say, a tube or a water channel carrying some water from a certain point to a next, right? And in the middle of that tube, there is a valve controlled by a lever, right? So with no current at the base, in the case of the lever, right, the valve would be totally shut off, and therefore restrict or do not allow the current, any current to flow through the transistor. And in the case of the channel carrying the water, no water will actually flow when the valve is completely closed. Now, as we start to increase the current flowing at the base or at the valve, we start to allow current to flow through the channel or through the transistor. So we actually use a small current at the base to control a much larger current at the collector, right? And that small current at the base is usually of the order of microamps, while that of the collector is usually of milliamps, right? So those are the things that we need to understand about a transistor, right? And as I said before, it's closely related to the diode. So essentially we can actually take two diodes and actually configure them in such a way that we have made a transistor, right? So that's pretty much it as it relates to the basics of transistors, right? As we go further and we actually construct a couple of circuits, we'll see how the applicability of transistors in everyday electronics is made use of, right? So again, this is Junior Roberts from realjuniorroberts.com, and thank you for watching.